Welcome back to my YouTube channel, and today I'm going to teach you what is state pattern. This video is a part of my low-level system design course, and I have a lot more videos on system design on my YouTube channel. So if you haven't already, go check it out and subscribe today. So what are we going to discuss today? First of all, before telling you what is state pattern, I'm going to tell you a real world problem. And then we are going to together solve it without using state pattern. And then we are going to see what problems will arise if we don't use state pattern. And then finally, we are going to implement the same problem, the solution for that in the state pattern so that you are able to understand in depth on what are the benefits of using state pattern and in what scenarios should you use this pattern. So I'm super excited. We are going to get started super soon. But before we get started, a little bit about myself. I'm Madhav and I run this channel, The Lean Programmer. So if you are new here, you should definitely go to my channel, youtube.com/the lean programmer. On my channel, I teach a lot of things and all those things are absolutely for free. I teach AI agents, I teach automation, I teach front end, and finally, I'm creating a whole free series on system design. You should definitely check it out. It's going to be super fun because everything that I teach is through real world example and hands-on coding. So without any further delay, let's get started. It's going to be super fun. So the problem that I'm going to give you is you have to create a whole customer support management system. What happens in customer support? Whenever a customer requires a new support or a complaint, a ticket corresponding to that complaint or request should be opened. So initially that ticket will be in the new state, and as soon as it's assigned an agent or a customer support representative, it will become in progress or active. Once they work on it, it can be resolved, and once it's resolved, we can communicate that to the customer, and when the customer says a go ahead, we can finally close the support ticket. So we have to implement this today. What are some common actions that can be added to the tickets? We can assign an agent. What should happen when we assign an agent? It should automatically go from new to active or in progress. However, if it's already in progress, it should just change the assignee, or if it's already resolved or closed, then we should not be able to assign to an agent. We should be able to reply to the customer. We should be able to resolve the ticket, close the ticket, reopen, escalate, and so on. For simplicity, we are just going to implement these four actions. You can anyways extend it. So the core problem is there are different actions and there are different states. However, the actions should be present irrespective of the state. But what will happen when we perform that action is dependent on the state. As I told you, if we assign an agent and if the ticket is in new state, it should automatically go to the active state and so on. So this is our problem. Let's start implementing it. So let's start coding. I want you to open a text editor of your choice or an IDE of your choice. For me, it's going to be VS Code. Forever, I love VS Code. And just create a new directory. Let's call it brute force implementation or bad code. I usually like calling it bad code because we're going to change it to good code afterwards. And since we are implementing a ticket management system, let's first of all create a class for our client. Let's call it ticketing system, or I don't know, customer support system or whatever. Then let's start creating a basic ticket. It's going to be a brute force implementation, obviously. So I'm going to call it a basic ticket. Basic ticket.java, there's no interface, nothing. There's just a class. What we can do is we can have an enum to maintain the state. We are going to call it ticket status. Ticket status. Ticket status can be new. It can be in progress. It can be resolved. It can also be closed. That's it. So inside our basic ticketing system, first of all, we are going to have a private string ID. Every ticket should have an ID, and then we are also going to have a status. Private ticket status. By default, we can keep it ticket status.new. All right. And now we are going to, or if you want, we don't need to initialize it. That's fine. Now let's have a constructor. We are going to call it public basic ticket. We can enter the string ID. someone else, let's assume someone is responsible for creating the ticket, or we can just initiate it with a new GUID ourselves, but that's not a problem. So for now, just focus. Don't worry too much about the ticket management system itself, but worry more about how we manage the tickets, how we manage the states and all. So let's see. Let's come to a very basic and a very brute force kind of an implementation. As soon as someone creates a ticket, it automatically applies the status as new. Perfect. So what all things can be there in the what all actions can be performed? We should be able to assign an agent, we should be able to reply to customer, resolve ticket, and close ticket. We are going to see these four actions in action today. If I'm going too fast, let me know. In future videos, I can be slow. So I'm going to create a few functions. Let's say the first function is assign agent. In this, we can have the name of the agent name. All right. And let's just add as I told you, the actions will perform differently based on the what? Based on the status. So we are going to obviously apply a switch case. Switch case on not the agent name. We are going to apply the switch case on status or this dot status. All right. So the first value is going to be new. In case of a new, let's just print it out that hey, um, ticket assigned to. What I'm trying to say is there will be some logic here. There'll be some logic here. In real world, it's not going to be just some print statements, obviously. But this is just for your reference here. So if it's already closed, then again was already closed. Perfect. Now just assume as right now we just have some logic. But in real world, there'll be a huge logic to assign, maybe not huge, but then there'll be specific logic to assign this ticket to an agent, right? And we are going to define that logic based on the ticket status, depending on this switch case and so on. Yeah, perfect. So now let's implement the second one. What was our second function? The second function was reply to customer. Perfect. So let's just copy and paste this whole thing. All right. And let's call it reply to customer. Instead of agent name, now we have a message. All right. Message. And finally, if it's closed, then let's say cannot reply. Was closed, cannot reply. That's it. So obviously in the real world, this function would be different, but you have to understand the structure. So the structure is this switch case. A huge switch case here, a huge switch case here, and in our other two functions as well. Do you remember what was the next function? The next function was public void resolve. Resolve. All right. And then the same switch case. So the new status ticket cannot resolve without starting the work, right? Cannot resolve as the work or cannot resolve start the work first. Perfect. A ticket in progress can be resolved. So you can say resolving the or mark as resolved. Perfect. If it's already resolved, was already resolved, this much should be enough. All right. And if it's already closed, then cannot resolve. Simple. And then finally, we have to implement a close function as well. It's going to be exactly the same. A ticket in new state cannot be closed. It needs to be start first. The work should be started. Again, in progress cannot be closed first. Cannot close. Complete the work first or resolve the ticket first, whatever was, or you can say resolving the ticket now. Perfect. Was already closed, cannot closed, whatever. Was already closed. As simple as that. So we have this ready and we have our whole ticketing system ready. What we are going to do is add a main function. Inside our main function, let's indentate it first. Inside our main function, we are going to create a basic ticket. Let's call it ticket equal to new basic ticket with an ID. Let's call the ID 1234. Perfect. Ticket dot assign ticket. I'm going to assign this to, we're going to assign it to Joe. And then in the ticket, we are going to first of all say reply to customer. We're going to say, hello, how can I help you? Blah, blah, blah. And then finally, once the work is done, we can resolve it, and then we can close it as well. We can still reply to customer. Let's say what happens when we reply to customer. Reply to customer. Let's say we try closing it again. It will not, it should not, and let's see what happens. Reply to customer, and then after that, thank you for patience. Perfect. Now let's try to run it. Allow. Perfect. So see, first of all, it was well, as soon as the ticket was created, it was assigned to Joe, and the ticket status should have been marked as in progress. Then updating the customer, hello, how can I help you, Joe? Marked as resolved, and then we tried to close it. It did not close. Why did it not close? Yes, because when we resolved it, we did not mark the status as uh, ticket status dot resolved. Oh, I marked the status here. See, so everyone can do mistakes. It's completely fine, but learning from them and how fast can you fix them matters. Okay, so assigned, hello, how can I help you? Marked as resolved, resolving ticket now, was already resolved, blah, blah, blah. And then finally replying to customer, still sending the message. And finally, I think we missed one thing. For close as well, we need to mark the status as status equal to ticket status dot closed. Perfect. So we have our working code ready, but what's the problem with this code? Why am I calling it a bad code? So as you can see, every every single every single method had too many conditionals. So every single method had conditionals. Now just assume, let me close this once again. Let's assume as of now, it's just one print statement. But in real world, this will be a huge logic. So just imagine how complex our system will become. So many conditionals. And trust me, guys, if in real world systems, if there are these many conditionals, it becomes very disorganized and very difficult to maintain. How do you scale it? As of now, we just created four functions. There can be more functions. Let's say escalate ticket. There can be get customer reply. There can be n number of more functions. Are you going to add more conditionals in each of the function? That doesn't scale well. That does not scale well. And then every time we have to change a logic, we'll have to think about each state. It's going to be super complex, and we can easily miss adding. Let me show you an example. Let's say there's an intermediate state, escalated, but you added escalated to, let's say, reply to customer. But what if you did not add the escalated to assign agent? What if you did not add the escalated to a new function that you are adding? You can easily miss these things. So it's going to be not good. So principal violation, open close principle, OCP, as I have been telling you in a lot of my previous videos, your code, oh, no, not OCP, OCP, your code should be open to extension, which means you should be able to extend your code, but your close should be closed to modification, which basically means that you should be able to modify, or you should be able to extend your code without making any changes to the existing code. But here, if you, let's say, add a new state, or if you add a new function, you will have to modify the existing code. As I told you, if you add an escalated state, you'll have to add an escalated state. In each of these, you'll have to modify the existing code and you cannot extend your code without modifying it. All right. So here comes the state pattern to the rescue. So what state pattern basically is state pattern defines the state specific behavior to separate classes. It enables an object to delegate actions to its current state. Let's see what it means. So let's assume you have a gate, all right, and this gate can be logged or unlogged. And you already know it's similar example as the ticket system. There can be two options, two actions, inserting a coin and pushing it. So inserting a coin will should work only if the gate is locked. In an unlocked gate, you should not be able to insert the coin. And similarly, pushing to close it should work only if it's unlocked. It should not be able to unlock it. It should not work when it's locked. So two actions depends on the state. So this is again an example of where you can implement the state pattern. So any problem that you see in life where you see specific states of the system, open, closed, active, resolved, new, logged, unlogged, and so on. If you see a state of the system, this is your hint that you have to apply the state pattern. All right, let's see how the classes are represented in individual states. So there are four roles here, basically three, because client is present in almost every row, every kind of pattern. But yeah, so first of all, you'll have a context class. So context class holds the current state. What? So you can assume, you can think of it as it's the ticket which knows that it is what's the status of the ticket, right? So that should be able to hold the state. Then the state interface. It defines what what all functions are mandatory to be implemented. So that any class which inherits the state interface is going to be of a type state, and it should be able to, it will be forced to implement all these functions. So for example, as I was telling you, if I add a new status, let's say escalated, I can, in this kind of a pattern, I can easily miss adding it here or here or here. But if you create a separate class and if you inherit that class, or if you implement that interface. So if you implement that interface, you will be forced to implement each of these functions. So you can easily extend the status to a new status without modifying the existing classes, and while making sure that every function is implemented. And all those implementations are called the concrete states. So it's going to look like this. There'll be a context, there'll be a set state and the request. You can have n number of functions as you want, obviously. And then there'll be so context should be able to set the state, and the state should be able to handle whatever functions are needed. And then there'll be a concrete implementation of these states. Perfect. So let's start the code. I hope you're excited. If you want, you can take a break, pause this video, go and drink water, and come back. So now let's come back to the good code, or the code which follows the state pattern architecture, state design pattern. All right, so as every time we are going to create a client, or you can call it ticketing system, I'll just call it client for now. All right, so we are going to have a main function here, but we are going to come to it after some time. So we have to first of all create a ticket, right? So let's create a new ticket.java. How is that ticket going to look like? Same thing, it's going to again have a private string ID, just like that. But in now, instead of ticket status being an enum, we are going to create a private ticket state. This is the interesting thing. So let's try to add the ticket state. But before we add the ticket state, we have to add the ticket state interface. As you remember, we need a interface. We need an interface that defines, that enforces what all functions need to be implemented. So let's start a ticket state.java. Is this time it's going to be an interface, and we need four mandatory functions. First of all, it's going to be assign agent. Assign agent needs to take in ticket. Why am I taking in the whole context object itself, ticket itself? Why am I taking it? Because when we assign the agent, we need to update the ticket. So ticket maintains a state. The state can be new, in progress, closed, or resolved. But when I assign the agent, it should automatically go from new to active. That's why I'm passing as string agent name, obviously. Then the next function needs to be, wait, what is this? Yeah. The next function obviously needs to be void reply to customer. Same thing, ticket, string message. Let's make it quick. Void, two more functions. Resolve, ticket, void, close, ticket. Perfect. Now our ticket state is ready. Perfect. So now let's create individual states. Let's start create with the creation of new ticket state dot java. So this basically means this is the representation of the new state, right? So I'm going to call it implements ticket state. All right, we're going to override all those methods, right? Right. Let's override. So we added the overriding of all those. I am just going to copy this. Should I copy it or I can actually write it on my own, but I won't add too many out print statements this time. Let's just say assigning to agent. There's no need to spend too much time into writing all this. This is anyways the dummy code, right? This is just for your understanding. And then I'm going to say ticket dot set state. Set state. So this should have a method, but this does not have a method now. So let's come back to the ticket state. I hope you're trying to understand. If you're not, let me know in the comments. I would be happy to help. But you need to remember that this is the pattern. So there's this context class. In this case, ticket is our context class which maintains the state. All right. Inside the state ticket, we should be able to create set the state. Set state, and in the set state we should be able to take the state of the ticket, right? And then we should just say this dot state equal to state. Let's also add a constructor, public ticket. Let's just take it an id for now. Id, yeah, ticket id, and then this dot id equal to id, and let's say this dot state equal to new ticket state, obviously. So new ticket state implements the ticket state. Ticket state is our interface. I hope you're trying to understand. Let's go back to the roles. There's going to be a state interface which enforces all the methods that should be implemented on a state. State can be a new, state can be in progress, resolved, closed, and so on. And then there's the context, which actually holds the state. The context holds the state. Remember, the context holds the state of the ticket. So in through our context, we should be able to assign the new state, right? So new ticket, set state, ticket dot set state. I'm going to say new in progress state. So we don't have an in progress state, right? Because obviously after assigning to the agent, we should be able to add an in progress. Let's say in progress state dot java. It's again going to implements ticket state. Let's add all the methods, all the overrides. Perfect. So now we can come back. We are going to implement all of this very soon, very, very soon. But for now, let's come back to our new state and we are going to say new in progress state. That's it. So did you understand what just happened here? Basically, as soon as the user calls, but the user, will they be calling an assigned agent here? No, the user will be calling an assign agent on the ticket. So we need to add a assign agent here as well. Public assign agent string, it should be void string agent name, and in our agent name we can just say this dot or state whatever, this dot state dot assign agent this comma agent name. So just try to understand what's happening here. All right, so basically as soon as the ticket is created, we will add a new id. And we are assigning the state to the new state. So instead of the state being an enum here, it's basically an implementation of the ticket state interface, which defines all four of those methods. And when the client calls assign agent function on our ticket, we're just going to call the assign agent on the state. And what it does is it assigns to the agent and then it marks the ticket state as in progress state. All right. Reply to customer, same thing. Let's say replying to customer message. All right. And then finally, we're going to say this dot ticket, no, ticket dot, no, assign agent, set state. In progress state. So even when if we are replying to the customer, it means the ticket is being looked upon, which means it's actually in progress. So that's it. And then resolve, you cannot resolve, just an error. Cannot resolve a new ticket. Simple. Close, simple. Cannot close a new ticket. As simple as that. So our new state is implemented. Now let's go back to the ticket. There should also be a method to what? Reply to customer here. Reply to customer and simple. It's we should be able to reply. Remember all the four methods that I told you. Reply to customer and all of those. Reply to customer, close, resolve, right? So this dot state dot reply to customer, same thing. I hope you're understanding it now. So what should happen if it's a new ticket and if you reply to customer, it should go to in progress. But if it's already in progress, then what should happen? First of all, if it's already in progress and if we assign the agent, then we can just say that uh, reassigning the ticket to agent name. Perfect. Now reply to customer. What should happen if we reply to customer on a active ticket? Tell me what should happen. Nothing. It should just reply to customer. Replying to customer. Simple. But if the user resolves it, it's an in progress. So it should be able to resolve. Resolving the ticket. And then it should say ticket dot set state a new what resolved state, but we don't have a resolved state now, so let's implement it. It's going to be super fast. I know I'm going super fast, but uh, try it yourself. Look at the code. All right, github.com/madhavhel, and then you can follow me, and then you can go to the system design course, right? You can go to the system design course and you can see all the code that we have here. You can see all the code. Perfect. So what I'm trying to say to you is read the code again. You should be able to understand. And if you're still not able to understand, just let me know, ask in the comments. I'm here to help you. I would love to help you. So now let's create a new resolved ticket state.java. All right, it's again, we need to implements ticket state. Again, the same four things. Let's copy and paste the in progress one. Same thing, assign agent, we cannot assign to a resolved one. So I'm just say ticket resolved, cannot assign. Simple. And here reply to customer, we can ticket is resolved, but still replying to customer, whatever. And resolve. What should happen? Resolving the ticket. No, ticket is already resolved. Ticket is already resolved, right? Now let's come back to the close implementation in just some time. But for now, let's come back to the in progress. So in progress, if you resolve an in progress ticket, you should be able to, okay, if it's becoming confusing, let's go back to our diagram. We should be able to assign an agent to a new one. For an in progress, we should be able to resolve it. And for a resolved one, we should be able to close it. We should not be able to directly close the new tickets, right? So this was the catch. Now let's go back here. So we'll just set state to resolved ticket state. Perfect. And now close. You cannot close an in progress, so I'll just throw an error. Close an in progress ticket. Perfect. Now finally, let's come back to the resolved. So in the resolved, we need to resolved ticket should be able to be closed. So let's say closing the ticket, and we need to say ticket dot set state to a new what? Resolved nahi, closed state. So let's create a closed ticket state dot java. Perfect. And it's again going to implements ticket state. Again, all these four methods exactly the same. Assign. As of now, you're seeing that this is copy paste, but when you actually start implementing, these won't be copy paste because these will be some individual methods. Every state handles individual methods differently. So assign ticket resolved, ticket closed, cannot reassign. Reply to customer, ticket is closed, cannot reply. All right, and then resolve ticket is already closed. And if you, this is the closed ticket, ticket is already closed. Yeah, is already closed. Perfect. So this is, so in basically in closed state, you pretty much cannot do anything. So new closed ticket state. Perfect. Now let's come back to our ticket and just implement these as well. Public void resolve this dot state dot resolve of this. Public void close, and then this dot state dot close of this. As simple as that. So we have made a whole ticket management system in a very scalable way. Let's see how it works. So in our client, we can create a new ticket equal to new ticket with an ID. Let's call this as ABCD this time, ABD, whatever. Then we can create ticket dot assign agent. Let's assign to Jim this time. Ticket dot, after assigning is done, we can reply to customer, hello, how may I help you, whatever, and then we can resolve it. Ticket dot resolve, wait, resolve, then we can say ticket dot, let's try to close it directly. It should not be able to close. All right, and then let's say ticket dot close. After ticket dot close, let's say assign agent Jimmy. So this should not work, this should not work, everything else should work. Let's see if it works. All right, so first of all, cannot assign a new, cannot close a new ticket, perfect. Assigning to agent Jim, perfect. Replying, hello, how may I help you? Resolving the ticket, closing the ticket. And then if I assign it after closing, it cannot assign. That's it. Let's go over our implementation super quickly. So we have a context. Our context is the ticket. Ticket maintains the state, right? And in the state, it also allows to set the state. Perfect. Then we have a concrete state implementation. First of all, we have a state interface. In this interface, we add the functions which we have to enforce all the states to implement. And then we have a concrete implementation of all the states, new state, closed states, and so on. So we can add all the actions. So these are actions, right? So ticket should be able to perform various actions, but each separate, all the action depends on the state, as I was telling you initially. And in this case, each state is responsible for maintaining its own action. Now, this fully supports open closed principle. How? If you have to add a new state, we don't have to change any single thing in this. Anything. You won't touch the context, you won't touch the client, you can just add a new state. You can just add a new ticketing system, right? So this is how our ticket management, this time we created a bigger app. Our previous apps used to be smaller. So if you haven't already, go check out my system design course. It's awesome. I loved this course because I'm putting in a lot of hard work to teach you everything for free. So I've created this UML diagram. As you can see here, we have a ticket, which is our context. We have an interface ticket state. And do you see the runtime polymorphism here? We basically, so our ticket maintains the state and assign agent, reply to customer. All of this happens in the runtime depending on whatever state is passed. We are not we are maintaining it on ticket state and not really, it's not like we are having different things for new ticket state. It's not like we are having different things for resolved ticket state. We are just maintaining it for common ticket state. So it decides which one to call based on the current state. Do you see? It's runtime polymorphism. Such a beautiful code. So how it works, I already told you. State responsibilities, you already know. Benefits of this, it eliminates the conditionals absolutely. You won't see any sort of if else or any sort of switch case here. All the behavior is grouped. So every action that can be performed on closed is grouped within the closed ticket system. Improves the readability. It's so simple to read. What can a closed ticket do? It can assign, it can reply, whatever, right? And it follows open to extension, close to modification principle. Benefits, you can add a new state. You can, as I told you, with minimal code changes, you can add new state, you can add new actions, and the existing code remains largely untouched. Very easy to extend, very future proof, and it also complies with OCP. Improved maintainability, clear life cycle. As you can see, each state has a clear life cycle. In our initial bad code, we did not know the life cycle of each function. We have to write it down in the conditional statements, and it's almost impossible to reach invalid state. It safeguards, as I told you. You can never, in this one, if you extend, let's say, if you, as I told you, if you add a new state, escalate, and if you miss adding that behavior for escalated in uh, any of these functions, it your code becomes prone to bugs. But here it's impossible. If you add a new if you add a new ticket, let's say escalated, it will have to implement all four of these, otherwise it will give you an error. When to use? When you see a object's behavior being dictated by its internal state. For example, support tickets, order processing. Order processing can be shipped out for delivery, processing, and so on. User session, game developments. In game development also, like it depends on what kind of game you're playing, but uh, let's say an RPG game, the character is alive, the character is what's the HP, whatever. Media players and UI flow control. And that's it for today's video. I hope you learned something new, but I have a homework for you. Go through this code once again, go to LinkedIn and share with everyone what you learned today and tag me. I really, really want to see how many people actually made it till the end of this video. It was a long video, but we learned a lot here. So do post on LinkedIn and I'll see, do tag me. I'll see what did you learn today. I'll talk to you in the next video. Till then, keep watching all my videos on my YouTube channel, youtube.com/the lean programmer. See you next time. Bye bye.